Hi everyone, welcome back. In this video, we will discuss the top Spring Boot interview questions and answers for candidates with 2 to 3 years of experience. Let's get started. What is Spring Boot and what are its main features? Even though the question sounds simple, your explanation must be clear, structured and confident. So let me help you build the perfect answer. Let's start with the core idea. Spring Boot is a framework built on top of the Spring framework. Its main purpose is to make Java application development easier, faster, and far more productive. Before Spring Boot existed, developers wrote a lot of configuration manually. They created XML files, registered beans, configured servers, and managed dozens of setup steps themselves. Even small applications required too much effort and too much configuration. Spring Boot solves that problem completely. It removes heavy configuration, it provides sensible defaults, it auto-configures commonly used components, and it helps developers build production-ready applications with minimal effort. That is why companies love Spring Boot. That is why interviewers focus on it. And that is why it has become the standard for modern backend development. Now let's put this in interview style. If the interviewer asks, "What is Spring Boot?" your answer can begin like this. Spring Boot is an opinionated framework built on top of Spring that simplifies Java development. It provides auto-configuration, starter dependencies, and an embedded server, allowing developers to create standalone production-ready applications quickly with minimal setup. Let's break that down so you can speak it naturally. When we say Spring Boot is opinionated, it means Spring Boot makes smart decisions for you. It chooses sensible defaults. It configures the common things automatically. You don't worry about choosing the correct JSON version. You don't manually configure the dispatcher servlet. You don't manually set up Hibernate or the server. Spring Boot handles all of that behind the scenes. The next major feature is auto configuration. This is the heart of Spring Boot. Auto configuration scans your class path, checks your dependencies, and configures the components your project needs. If you include Spring Web, Spring Boot sets up the dispatcher servlet, JSON handling, error handling, and the embedded Tomcat server automatically. If you include Spring Data JPA, it configures Hibernate, the entity manager, transaction management, and connection pooling. You start writing business logic immediately. Another key feature is starter dependencies. Spring Boot provides prepackaged sets of libraries. Instead of manually searching for compatible library versions, you add a single starter. Starter Web gives you everything for building REST APIs. Starter Data JPA gives you everything for JPA. Starter Security gives you everything for authentication and authorization. These starters eliminate version conflicts and make dependency management clean and simple. Now let's talk about the embedded server. Before Spring Boot, you deployed applications as WAR files into external servers like Tomcat or Jetty. With Spring Boot, the server is built in. When you run the application, Tomcat or Jetty or Niti starts automatically. No installation, no deployment, no manual configuration. This feature is one of the biggest reasons Spring Boot became the foundation for microservices. Each microservice runs independently, has its own server, and is very easy to deploy. Let's connect this directly to microservices because interviewers always look for this point. Spring Boot is widely used to build microservices because it produces small, self-contained, standalone applications. When combined with Spring Cloud, you get service discovery, API gateway routing, distributed configuration, load balancing, and fault tolerance. Together, they form a complete microservices ecosystem. Another major feature is Actuator. Actuator gives you production-ready endpoints for monitoring your application. You can view health checks, metrics, environment details, and system information instantly. You don't write any extra code. Actuator provides everything out of the box. This is incredibly helpful for microservices, cloud deployments, and production monitoring. Spring Boot also improves the development experience with DevTools. DevTools automatically restarts your application when you change your code. It also supports live reload for templates. This saves time and makes your development workflow feel smooth and fast. Another important area is configuration management. Spring Boot supports externalized configuration using properties or YAML files. You can create multiple profiles for different environments like development, test, staging, and production. The same application behaves differently based on the active profile. This keeps your configuration clean and avoids hard coding values. Now let's put everything together into one strong, clean, interview-ready answer. Spring Boot is a modern, opinionated framework built on top of Spring that simplifies Java development. It removes boilerplate configuration and offers features like auto configuration, starter dependencies, and an embedded server. These features help developers build standalone production-ready applications very quickly. Spring Boot provides Actuator for monitoring, DevTools for rapid development, and external configuration support for managing environments. Because it is lightweight, fast, and easy to deploy, Spring Boot is widely used to build microservices and cloud-native applications. Overall, Spring Boot reduces complexity, increases productivity, and helps teams deliver scalable applications faster. If you speak this confidently, you will immediately stand out in any interview. What is the difference between Spring and Spring Boot? This is a very common question, and if you explain it clearly, the interviewer will instantly see that you understand both frameworks, their purpose, and how they evolved. So let's break it down in a simple, structured, and beginner-friendly way, based on the comparison you saw in the diagram. Let's begin with the primary objective. Spring Framework is a comprehensive Java platform designed to give developers tools for building large-scale enterprise applications. It focuses on providing infrastructure, dependency injection, AOP, transaction management, template utilities, and many other lower-level features. But Spring Boot has a very different mission. Spring Boot is built on top of Spring, and its primary goal is to simplify Spring application development by giving you auto configuration, sensible defaults, and runtime simplicity. In simple words, Spring provides the foundation, and Spring Boot makes that foundation easy to use. Now let's talk about configuration. With Spring Framework, you have to configure almost everything manually. You set up XML files, define beans, configure view resolvers, and integrate the tools yourself. It is powerful but requires a lot of effort. Spring Boot solves this by providing auto configuration and opinionated defaults. Instead of writing manual configuration, Spring Boot configures most things automatically based on the dependencies in your project. This dramatically reduces setup time and eliminates boilerplate. Next is project setup. Spring applications traditionally required a lot of initial work. You had to add many dependencies, choose compatible versions, and create a proper project structure. Spring Boot makes this extremely easy. It provides the Spring Boot initializer where you select your dependencies and instantly generate a ready-to-use project in seconds. This alone saves hours of manual setup. Let's move to web servers. Spring Framework relies on external servers like Tomcat or Jetty. You typically deploy your application as a WAR file into those servers. Spring Boot completely changes this experience by providing embedded servers. Tomcat, Jetty, and Undertow are built directly into your application. You simply run your Spring Boot application as a standalone jar, and the server starts automatically. This makes development faster and deployment much simpler. Now let's understand deployment differences. Spring Framework typically generates war or year files that are deployed to external servers manually. Spring Boot applications usually generate standalone jar files that already contain the embedded server. You run the jar file and your application starts instantly. No deployment steps, no external server installation. This is a huge advantage in microservices and cloud environments. Speaking of microservices, let's compare those next. Spring Framework requires manual setup and integration of several tools to build microservices. Spring Boot, on the other hand, works seamlessly with Spring Cloud and provides everything needed for microservices: service discovery, load balancing, API gateway, centralized configuration, tracing, and more. This makes microservice development straightforward and production ready. Let's also discuss production ready features. With Spring Framework, you need external tools or manual configurations for monitoring, health checks, logging, and application metrics. Spring Boot provides these out of the box using Actuator. You get health endpoints, metrics, environment details, and monitoring support without writing any additional code. This is especially valuable for real-world deployments. Next is properties and configuration. Spring Framework requires manual configuration of property sources and hierarchy. You decide where properties come from and how to manage them. Spring Boot simplifies this by giving you a unified configuration approach using application properties or YAML files. It also supports environment-specific configurations, making your application easy to deploy across dev, test, staging, and production. Let's move on to testing. In Spring Framework, testing often required additional configuration for mocks, integration tests, and loading context. Spring Boot improves this significantly. It provides built-in testing support using @Spring Boot test, @Mockito Bean, and auto-configured test context. This reduces complexity and makes testing far easier. Now let's put this into a clean interview-ready explanation you can speak confidently. Spring Framework is a comprehensive platform that provides low-level infrastructure for building Java applications, but it requires a lot of manual configuration. Spring Boot is built on top of Spring and focuses on simplifying development through auto-configuration, embedded servers, sensible defaults, and production-ready features like Actuator. Spring typically uses external servers and war deployment, while Spring Boot uses embedded servers and produces standalone jar files. Spring Boot also integrates more easily with microservices tools using Spring Cloud and provides a much easier learning experience. If you deliver this answer with confidence, you will clearly demonstrate your understanding of both frameworks. What's the difference between @Bean and @Component? Both are used to define beans in the Spring context, but they work in slightly different ways and are used in different scenarios. Let's walk through the full comparison step by step using this diagram. Let's begin with what they actually are. The @Component annotation is used to mark a class as a Spring managed component. When you use it, Spring automatically detects the class during component scanning and adds it to the application context. In contrast, the @Bean annotation is placed on a method, usually inside a class annotated with @configuration. It tells Spring that the object returned by that method should be registered as a bean in the Spring context. So simply put, @Component is class level and @Bean is method level. For example, consider we have a car service class which is annotated with @Component annotation. So Spring automatically detects this class during component scanning and adds it to the application context. With @Bean, you take control and tell Spring how to build the bean yourself using a configuration class. Now let's look at how they work. When Spring starts up, it scans your project for classes annotated with @Component, @Service, @Repository, and @Controller. These are all specializations of @Component, and Spring automatically creates instances of them, but @Bean is different. It doesn't rely on scanning. Instead, it's manually declared inside a configuration class. You write a method and Spring executes it to create and register the bean. So with @Component, Spring finds and registers the bean for you. With @Bean, you take control and tell Spring how to build the bean yourself. For example, imagine we have a payment service class. If it's annotated with @Component, Spring picks it up automatically. But if we use @Bean, we define it manually inside a configuration class, giving us full control over how the bean is created. Let's talk about when to use each. Component is ideal when you are writing your own classes for services, repositories, or controllers and want Spring to discover and manage them automatically. On the other hand, use @bean when you need full control over the bean's creation. A great example is when you want to register a third-party class or library that you didn't write and can't annotate with @component. So @component is automatic and lightweight. @bean is manual and flexible. For example, let's say you are using JSON's object mapper from a third-party library. Since you can't modify that class to add @component, you use @bean to register it manually with any configuration you need. Now let's look at flexibility. With @component, you are letting Spring handle instantiation using the default constructor or through constructor injection. But @bean gives you full control. You can run logic inside the method, pass in other beans as parameters, and return any object you want. That makes it useful for more complex configuration scenarios or when you need to use factory methods. It's like choosing between automatic and manual mode. Component is automatic. Bean lets you drive. For example, let's say you have a mail sender bean and you want to use it while constructing an email service. With that bean, you can pass mail sender as a parameter, write logic, and return a fully initialized service. Another key difference is where they are used. @component goes directly on the class you want to manage, but @bean must be used inside a class annotated with @configuration. That's how Spring knows where to look for your bean producing methods. Think of a configuration class as a blueprint, and each method marked with @bean is a recipe for creating one specific object. For example, take notification service. You can either annotate the class with @component or define a method inside a @configuration class using @bean. So to wrap it all up, use @component when you are writing your own classes and want Spring to find and manage them automatically during scanning. Use @bean when you need full control, either for third-party classes, complex initialization, or special conditions during bean creation. They both result in beans in the Spring context. The difference lies in how they are created and where they are defined. I hope this clears up the confusion between @bean and @component. Thanks for watching. Hey everyone, welcome back. In this video, we are going to clearly understand the difference between @controller and @Rescontroller in Spring Boot. These two annotations might seem similar at first glance, but they serve different purposes, especially in how they handle web responses. We'll walk through the differences side by side. So if you are preparing a Spring Boot backend or building APIs, this breakdown will help you decide when to use which. Let's dive in. Let's start with the main purpose of each annotation. @controller is used in Spring MVC applications where the goal is to return a view, usually an HTML page. It's part of the traditional model view controller architecture where the controller returns a view name and Spring resolves it to a template like a JSP or timelyf file. On the other hand, @Rescontroller is used when you are building RESTful APIs. It returns data like JSON or XML directly to the client instead of a view. It's commonly used in backend services, mobile APIs, or web apps built with JavaScript frameworks. So @controller is for web pages, yet @Rescontroller is for web services. The biggest practical difference is in the response. With @controller, if you return a string, Spring Boot assumes it's a view name. It tries to render a page using that name. For example, returning home will make Spring look for a home.html or home.jsp. But with @Rescontroller, returning a string sends that string as the actual HTTP response body. If you return hello, the user will literally see the word hello in the browser or as part of the API response. So @Rescontroller tells Spring, don't look for a view, just write this to the response body. Let's see the underlying annotations. @controller is a direct annotation to create a Spring MVC controller that returns a view. It won't do automatic JSON conversion. On the other hand, @Rescontroller is a shortcut annotation. Behind the scenes, @Rescontroller is simply a combination of @controller and @response body. The @response body part tells Spring to automatically serialize the return value into JSON or XML. and write it to the HTTP response. So instead of writing at controller on top and at response body on every method, you can just use at REST controller once at the class level. It saves you code and keeps things cleaner. So when should you use each one? Use at controller when you are returning HTML views. This is great for server-side rendered pages, admin panels, dashboards, or when you are building with Thymeleaf, JSP, or FreeMarker. Use at REST controller when you are exposing data. Think of REST APIs for front-end apps, mobile apps, or microservices that send and receive JSON or XML. So if your front-end is React or Angular, or if you are building API endpoints, you will almost always use at REST controller. Let's compare how they behave with the same return value. If you use at controller and return dashboard, Spring tries to find a view template named dashboard.html. But if you use at REST controller and return dashboard, the response is just plain text. It literally returns the word dashboard as raw output. This small change completely shifts how the app responds to the client. You can mix the two annotations in the same application. For example, your API endpoints can use at REST controller and your admin pages can use at controller. They work together in the same Spring Boot project. It all depends on your specific needs. Just remember, if you are working with views and templates, stick with at controller. If you are returning structured data like JSON, go with at REST controller. To wrap it all up, at controller is for serving web views like HTML pages. It follows the traditional MVC pattern and Spring resolves the view using a template engine. At REST controller is for serving data, mostly in JSON format. It's a shortcut that combines at controller with at response body, and it's perfect for APIs and modern web applications. Understanding the difference helps you build cleaner, more efficient Spring Boot applications. Next, how does Spring Boot auto configuration work internally? Spring Boot auto configuration works by examining the application environment at startup and automatically creating beans based on predefined conditions. When a Spring Boot application starts, it scans the class path to check which libraries are present, which beans already exist, and what configuration properties are defined. Internally, auto configuration is enabled using the AT-enable auto configuration annotation. This annotation loads many auto configuration classes listed in Spring Boot's internal configuration files. Each auto configuration class is protected by conditions. These conditions decide whether a configuration should be applied or skipped. For example, if Spring Boot detects that Spring MVC is on the class path, it automatically configures the web layer components. If a database driver is found, it creates a data source automatically. If a developer defines their own data source bean, Spring Boot backs off and does not create the default one. This behavior is called conditional configuration. It ensures that auto configuration never overrides developer-defined beans. In real interviews, experienced candidates must explain that auto configuration is smart defaults, not magic. It works only when conditions match and always allows customization. This design makes Spring Boot flexible and safe for large production systems. Hey everyone, welcome back. In this video, we are going to break down the difference between two commonly used Spring Boot annotations, at request param and at path variable. You might have seen both used to extract data from HTTP request, but how do they differ? When should you use one over the other? We are going to walk through this side-by-side comparison, and by the end, you will be able to use both with confidence in any Spring Boot REST API. Let's get started. Let's begin with what each one actually does. Request param is used to extract data from query parameters. That's the part of the URL that comes after the question mark. For example, if the URL is /search ? Keyword equals laptop, keyword is a request parameter. On the other hand, at path variable pulls data directly from the URI path itself. That means the value is embedded within the URL structure like /products/42, where 42 is a path variable. So to summarize, at request param reads values from the query string, and at path variable reads values embedded in the actual path. Now let's talk about where they live in the URL. At request param, values appear after the question mark in the URL. You might see something like /users ? country equals India, and age equals 25. Those key value pairs are request parameters, but with a path variable, the values are part of the route itself. You might see something like /users/25, where 25 is directly in the URL path, not as a named parameter. This difference affects how URLs are structured and how readable or shareable they are. Let's take a closer look with an example. Say we have a use case where someone wants to look up a specific user. If we use a path variable, the endpoint might look like /user/101, where 101 is the ID of the user. That's clean and direct, ideal for accessing a specific resource. If we use at request param, the same request could be written as /user?ID equals 101. This is more flexible when passing multiple optional values, but it's a little more verbose. So both work, but they are designed for slightly different purposes. Let's talk about when to use each. Use at request param when the value is optional, or when you have multiple filters, sorts, or search terms. It's commonly used in search APIs, filters, pagination, places where flexibility matters more than structure. Use at path variable when the value is required and directly identifies a resource. It's great for things like user IDs, order IDs, or anything where the path clearly points to one item. Here's another big difference: flexibility. At request param, values can be optional. You can set defaults or skip them entirely. This makes them perfect for advanced filters like show me products under $100 in stock sorted by rating. But at path variable, values are almost always required. If you define an endpoint like /user/ID, you can't skip the ID. It's expected to be there. So at request param gives you flexibility. At path variable gives you precision. In REST API design, the two also have different semantic meanings. So request param adds detail about how you want that resource, maybe sorted, filtered, or paged. It's about customization, not identification. At path variable represents a resource like a specific user, order, or product. The URL path is saying, get me this resource. So if your API is meant to be RESTful and intuitive, placing the ID in the path using at path variable is the more semantically correct approach. Let's wrap it all up. So request param is for values that come from the query string. It's ideal for optional filters, settings, and extra parameters. At path variable is for values that are part of the URL path. It's perfect for required, meaningful values that identify a resource. They both let your Spring Boot APIs receive input from the client, but the way they do it and the situations where they shine are quite different. In this lecture, we discuss what is Spring Boot DevTools. Spring Boot DevTools is a development time tool that improves the speed and smoothness of your development workflow. It is not used in production. It is not used for deployment. Its only purpose is to help developers work faster and get instant feedback while building applications. The main feature of DevTools is automatic restart. Whenever you change your Java code, your templates, or your resources, DevTools automatically restarts your Spring Boot application for you. You don't need to stop the app. You don't need to start it manually. DevTools watches for changes and restarts instantly. This saves you a lot of time because manual restarts slow down development, especially in medium or large projects. The second important feature is live reload support. DevTools can detect changes to HTML files, CS files, and static resources and reload them automatically in your browser. You don't refresh the page yourself. You don't open a new tab. Your UI updates instantly. This makes it extremely useful when you work with ThymeLeaf templates or front-end resources inside a Spring Boot project. Another useful ability of DevTools is disabling caching during development. Spring Boot usually caches templates to improve performance, but while developing, caching slows you down because your changes don't appear immediately. DevTools automatically disables caching, so every change is reflected instantly. This gives you a smooth development experience without additional configuration. DevTools also improves the class path handling by splitting the application into two class loaders. One contains the base libraries and the other contains your project classes and resources. Because of this, DevTools doesn't restart the entire application from scratch. It only reloads the part that changed. This makes the restart extremely fast. Another great advantage of DevTools is environment-based behavior. When DevTools detects that the application is running in development mode, it enables development-friendly settings automatically. But when the application runs in production mode, DevTools is completely disabled and ignored. This ensures there is zero performance impact in production. Now let's create an interview-friendly explanation. If the interviewer asks, "What is DevTools used for?" you can answer like this. Spring Boot. DevTools is used to speed up the development process by automatically restarting the application when code changes, enabling live reload for HTML and static resources, and disabling caching so changes appear instantly. It is designed only for development and improves productivity by giving immediate feedback without restarting the application manually. To make your answer even better, add a practical example. For example, when I update a controller method or modify a timelift template, DevTools instantly reloads the application or the page. I don't stop the server. I don't restart it manually. I simply save the file and DevTools refreshes everything automatically. This allows me to code faster and focus on building features instead of waiting for the application to restart. You can also mention one more small but important point. DevTools improves developer productivity, especially in large Spring Boot projects, because manual restart time grows as applications become bigger. With DevTools, the restart time remains fast and efficient, which directly improves the developer experience. In this lecture, we will discuss which embedded servers does Spring Boot support and how do you change the default. This is an important topic because embedded servers are one of the main reasons Spring Boot applications are so easy to run, package, and deploy. So let's break this down clearly and confidently. Let's start with the core idea. Spring Boot supports multiple embedded servers. An embedded server means the server is built directly into your Spring Boot application. You do not install anything separately. You do not deploy a WAR file to an external Tomcat or Jetty installation. You simply run your application and the server starts automatically. This is one of the biggest advantages of Spring Boot. Now let's talk about the servers that Spring Boot supports. The default embedded server is Tomcat. This means that when you create a Spring Boot web application using the Spring Boot Starter web dependency, Tomcat will start automatically. You don't configure it, you don't install it, it just works out of the box. The second supported server is Jetty. Jetty is lightweight, fast, and commonly used in environments where performance and scalability are important. Spring Boot provides full support for Jetty out of the box. The third supported server is Undertow. Undertow is known for its high performance and non-blocking architecture. It's a popular choice for reactive applications and lightweight microservices. Spring Boot supports Undertow just like it supports Tomcat and Jetty. So the three main embedded servers supported by Spring Boot are Tomcat, Jetty, and Undertow. Tomcat is the default. Jetty and Undertow are alternatives you can switch to very easily. Now let's move to the second part of the question. How do you change the default embedded server? This is actually very simple. Spring Boot automatically includes Tomcat because the Spring Boot Starter web dependency brings Tomcat with it. To change the server, you will remove Tomcat from your project and replace it with Jetty or Undertow. Let's understand this in an interview-friendly explanation. If you want to switch from Tomcat to Jetty, you exclude the Tomcat dependency from the starter web and then you add the Spring Boot Starter Jetty dependency. Spring Boot detects that Jetty is present on the class path and automatically configures it as the embedded server. The same applies if you want to switch to Undertow. You exclude Tomcat and add the Undertow starter. Spring Boot takes care of the rest. This means you never manually configure the server yourself. All you do is change the dependency and Spring Boot automatically switches the embedded server for you. This simplicity is one of the reasons Spring Boot is so powerful and developer friendly. Let's build a smooth interview answer now. If the interviewer asks which embedded servers does Spring Boot support, you can say Spring Boot supports Tomcat, Jetty, and Undertow as embedded servers. Tomcat is the default server that comes with Spring Boot Starter Web. If you want to change the default, you simply exclude Tomcat from the starter and add the Jetty or Undertow starter instead. Spring Boot automatically detects the server on the class path and configures it as the embedded server. To make your explanation even better, add a small example. For example, if I want to use Jetty instead of Tomcat, I exclude the Tomcat dependency and add the Jetty starter. When I run the application, Jetty starts automatically as the embedded server. I don't write any configuration. Spring Boot handles the entire process. This shows the practical understanding that interviewers appreciate. In this lecture, we will discuss what is Spring Boot Actuator. Spring Boot Actuator is a built-in module that provides production-ready monitoring and management features for Spring Boot applications. It exposes useful endpoints that help you understand what is happening inside your application while it is running. The goal is simple: to give developers and DevOps teams complete visibility into the health, performance, and internal state of the application without writing any extra code. Now let's explore what this really means. Actuator gives you endpoints that show health checks, metrics, application information, environment properties, thread details, request statistics, logs, beans, and much more. You enable Actuator and immediately your application becomes observable. This is extremely important in microservices and cloud environments where monitoring each service individually is critical. One of the most commonly used endpoints is the health endpoint. It tells you whether the application is up, down, or facing issues. It can also check the health of databases, message brokers, caches, and external services. This gives you instant feedback when something goes wrong. Another powerful endpoint is the metrics endpoint. This shows details about CPU usage, memory consumption, JVM statistics, HTTP request counts, response times, and much more. These metrics help teams diagnose performance issues, detect bottlenecks, and understand how the system behaves under load. Actuator also provides environment insights. You can see active profiles, configuration properties, environment variables, and system settings in one place. Instead of digging through logs or printing values manually, Actuator exposes everything instantly. There is also a very useful endpoint for beans. It lists all Spring Beans that are currently loaded in your application context. This is extremely helpful when debugging or trying to understand how Spring Boot auto-configuration has wired your application. Another important capability is log level management. With Actuator, you can dynamically change log levels at runtime without restarting the application. This is incredibly powerful during debugging in production because you can increase logging temporarily, collect the necessary details, and switch back, all without downtime. Actuator also integrates beautifully with monitoring tools like Prometheus, Grafana, Zipkin, and Micrometer. This makes it easy to build dashboards, track performance over time, and visualize metrics and trends. This is why Actuator is a must-have in microservices architectures where observability is critical. And now let's shape this into a strong interview explanation. If the interviewer asks what is Actuator used for, you can answer like this. Spring Boot Actuator is used to monitor, manage, and understand a running Spring Boot application. It provides production-ready endpoints such as health, metrics, environment, beans, and logs, which help developers and DevOps teams track the system's behavior in real time. Actuator improves observability by exposing details about performance, resource usage, configuration, and application state without writing any custom code. It is essential for microservices because it makes services easier to monitor, debug, and maintain. To make your answer even better, add a short, practical example. For example, when I enable Actuator, I can instantly check whether my database connection is healthy. I can monitor how many requests my API has processed. I can view memory usage, thread counts, active profiles, and configuration details. This gives me complete visibility into my application while it is running. You can also mention one more important point. Actuator exposes only safe endpoints by default. For security reasons, sensitive endpoints can be enabled manually and protected using Spring Security. This shows that you understand both functionality and security aspects. If you deliver this answer clearly, you will impress any interviewer. In this lecture, we will discuss what exactly does the Spring Boot application annotation do. Even though this annotation looks simple, it actually activates three major Spring Boot features behind the scenes. Let's start with the official idea. Most Spring Boot developers want their application class to do three things automatically. They want auto configuration, they want component scanning, and they want the ability to add extra configuration when needed. Spring Boot application brings all three of these features together in a single convenient annotation. So what does this one annotation actually enable? It activates three other core annotations under the hood. The first is at enable auto configuration. This is what triggers Spring Boot's auto configuration mechanism. It tells Spring Boot to look at the libraries on your class path and automatically configure beans for you. You don't manually set up Tomcat, Jackson, Hibernate, Data Source, or Spring MVC Spring. Boot configures all of that based on what it detects. The second annotation it enables is at component scan. This tells Spring Boot to scan the package where your main application class is located. It automatically detects components like at component, at service, at repository, and at controller. You do not register these beans manually. Spring Boot finds them, creates them, and wires them into the application context for you. This is why most Spring Boot projects just work when you structure them correctly. The third annotation it brings in is at configuration. This tells Spring that your application class can define beans. It behaves exactly like a Java configuration class. You can use @bean methods to create custom beans or import other configuration classes. This gives you full flexibility and lets you customize your application whenever needed. So, in simpler words, Spring Boot application is just a shortcut. It combines @configuration, @enable auto configuration, and @component scan using their default behavior. Instead of writing all three annotations separately, you write only one, and Spring Boot activates everything automatically. Let's make this interview friendly. If the interviewer asks, what does Spring Boot application do? You can say, Spring Boot application is a convenience annotation that combines @enable auto configuration, @component scan, and @configuration. It enables Spring Boot's auto configuration, scans the current package for Spring components, and allows the application class to register additional beans. It is the primary annotation that bootstraps every Spring Boot application. Let's strengthen it with a practical example. When you create a new Spring Boot project, your main class only has Spring Boot application. You don't add XML, you don't register controllers, you don't configure the server, you simply run the application and Spring Boot sets up everything automatically. Your controllers are discovered, your beans are created, your server starts, all because of Spring Boot application. If you speak this version clearly, you will give a precise, complete, and officially correct answer in any interview. Next, what are get mapping, post mapping, put mapping, and delete mapping? These annotations provide simplified mappings for common HTTP methods. Get mapping is used for read operations, post mapping for creating resources, put mapping for full updates, patch mapping for partial updates, and delete mapping for deletions. They improve readability because the HTTP method is part of the annotation itself instead of configuring it inside request mapping. These method-level annotations follow REST architectural conventions, ensuring that your API aligns with industry standards. They also make the controller code cleaner and more expressive. In interviews, it is important to mention that these annotations internally use request mapping with the specific HTTP method values, but they provide better clarity and simplicity, reducing confusion about which method handles which type of request. Next, what is at request body and how does Spring convert JSON? At request body tells Spring to bind incoming JSON from the request body into a Java object. When a client sends a JSON payload, Spring uses an internal converter, usually JSON, to map fields into the corresponding Java fields. This eliminates the need for manual parsing. The conversion is automatic as long as the names match. This annotation is mostly used in POST and PUT operations where the API receives structured data. Spring Boot auto-configures all necessary converters, making request handling seamless. Interviewers expect you to mention that at request body is essential for modern REST API and that Spring Boot handles the entire serialization and deserialization process transparently, reducing developer workload. Next, what is ResponseEntity and why is it used? ResponseEntity allows full control over the HTTP response. Instead of returning only data, you can also return status codes, custom headers, and structured output. For example, after creating a resource, you may want to return a created status code and a location header. ResponseEntity makes this possible. It also improves clarity and error handling by explicitly indicating the success or failure of each operation. Using ResponseEntity is considered a best practice in enterprise API because it provides predictable and standardized responses. In interview answers, emphasize that it helps build robust API where clients receive meaningful status codes rather than relying on defaults. Next, how does Spring Boot handle exceptions in REST API? Spring Boot provides a structured approach to exception handling so that errors return clean, meaningful JSON responses instead of default server pages. The framework supports annotations like exception handler for handling exceptions at the controller level and controller advice for global exception handling. You can customize messages, error codes, and additional metadata for consistency. This is crucial because clients rely on stable and predictable error formats. Proper exception handling also improves debugging and user experience. Mention in interviews that Spring Boot encourages centralized exception management, separating error logic from business logic, and ensuring the entire API behaves uniformly when unexpected conditions occur. Next, how does Spring Boot handle dependency injection and why is constructor injection preferred? Spring Boot uses Spring's dependency injection mechanism to manage object creation and wiring. The Spring container creates beans, resolves their dependencies, and injects required objects automatically. This removes tight coupling between classes and makes applications easier to maintain and test. There are multiple ways to inject dependencies, but constructor injection is generally preferred in real-world projects. With constructor injection, all required dependencies are provided at object creation time. This approach makes dependencies explicit and prevents the creation of partially initialized objects. It also supports immutability, which improves thread safety and reliability. Constructor injection works well with testing because dependencies can be easily mocked and passed during test setup. Field injection hides dependencies and makes testing harder. In interviews, experienced developers are expected to explain not only how dependency injection works, but also why constructor injection leads to cleaner, safer, and more maintainable code in large Spring Boot applications. Next, how does Spring Boot support logging and what are best practices in production? Logging in Spring Boot is essential for understanding application behavior and diagnosing issues. Logs capture important events such as errors, warnings, and application flow. Without proper logging, debugging production issues becomes extremely difficult. Spring Boot provides logging support out of the box, allowing developers to log messages at different levels such as error, warning, info, and debug. In production systems, logging should be meaningful and structured. Logs should explain what happened and include enough context to identify issues without exposing sensitive data. Excessive logging can harm performance and increase storage costs. Logging levels should be adjusted based on environment. Debug logging is useful during development, but should be avoided in production. In interviews, experienced developers are expected to explain why logging is important, how to balance log volume and usefulness, and how good logging practices help in maintaining reliable Spring Boot applications. In this lecture, we will discuss which embedded servers does Spring Boot support and how do you change the default. This is an important topic because embedded servers are one of the main reasons Spring Boot applications are so easy to run, package, and deploy. So let's break this down clearly and confidently. Let's start with the core idea. Spring Boot supports multiple embedded servers. An embedded server means the server is built directly into your Spring Boot application. You do not install anything separately. You do not deploy a WAR file to an external Tomcat or Jetty installation. You simply run your application and the server starts automatically. This is one of the biggest advantages of Spring Boot. Now let's talk about the servers that Spring Boot supports. The default embedded server is Tomcat. This means that when you create a Spring Boot web application using the Spring Boot Starter web dependency, Tomcat will start automatically. You don't configure it, you don't install it, it just works out of the box. The second supported server is Jetty. Jetty is lightweight, fast, and commonly used in environments where performance and scalability are important. Spring Boot provides full support for Jetty out of the box. The third supported server is Undertow. Undertow is known for its high performance and non-blocking architecture. It's a popular choice for reactive applications and lightweight microservices. Spring Boot supports Undertow just like it supports Tomcat and Jetty. So the three main embedded servers supported by Spring Boot are Tomcat, Jetty, and Undertow. Tomcat is the default. Jetty and Undertow are alternatives you can switch to very easily. Now let's move to the second part of the question. How do you change the default embedded server? This is actually very simple. Spring Boot automatically includes Tomcat because the Spring Boot Starter web dependency brings Tomcat with it. To change the server, you will remove Tomcat from your project and replace it with Jetty or Undertow. Let's understand this in an interview-friendly explanation. If you want to switch from Tomcat to Jetty, you exclude the Tomcat dependency from the Starter web and then you add the Spring Boot Starter Jetty dependency. Spring Boot detects that Jetty is present on the class path and automatically configures it as the embedded server. The same applies if you want to switch to Undertow. You exclude Tomcat and add the Undertow starter. Spring Boot takes care of the rest. This means you never manually configure the server yourself. All you do is change the dependency and Spring Boot automatically switches the embedded server for you. This simplicity is one of the reasons Spring Boot is so powerful and developer friendly. Let's build a smooth interview answer now. If the interviewer asks which embedded servers does Spring Boot support, you can say Spring Boot supports Tomcat, Jetty, and Undertow as embedded servers. Tomcat is the default server that comes with Spring Boot Starter Web. If you want to change the default, you simply exclude Tomcat from the starter and add the Jetty or Undertow starter instead. Spring Boot automatically detects the server on the class path and configures it as the embedded server. To make your explanation even better, add a small example. For example, If I want to use Jetty instead of Tomcat, I exclude the Tomcat dependency and add the Jetty starter. When I run the application, Jetty starts automatically as the embedded server. I don't write any configuration. Spring Boot handles the entire process. This shows the practical understanding that interviewers appreciate. So what exactly happens when you hit a Spring Boot REST API endpoint? Let's walk through the entire flow step by step. First, your client, whether it's a browser or a mobile app or Postman client, sends an HTTP request to your Spring Boot application. That request is received by embedded Tomcat, which is the default web server bundled inside Spring Boot. Tomcat listens on a port, usually port 8080, and it's ready to accept incoming connections. Once Tomcat accepts the request, it passes the request to the dispatcher servlet. Think of the dispatcher servlet as the central traffic controller in Spring MVC. It decides where the request needs to go and how it should be handled. It's responsible for managing the flow from entry to exit. The dispatcher servlet doesn't work alone. It calls out to something called handler mapping, which is basically Spring's internal map of all your REST endpoints. It checks the request's path and method, like get/products or post/login, and it finds the matching controller method that should handle the request. Once the correct controller is located, Spring calls that method, passing in any parameters it needs, like query strings, path variables, or request bodies. The controller does its job, processing the logic, interacting with the service layer if needed, and returning a result. Now, the controller has returned a Java object, like a response, DTO, or entity. But we can't send Java objects directly over HTTP. So Spring uses the HTTP message converter, which automatically converts that object into a format the client can understand, typically JSON or XML. This conversion is seamless and handled behind the scenes, based on the client's accept header. Once the conversion is complete, the final HTTP response is assembled, including status codes, headers, and the response body. That response is sent back from the dispatcher servlet through Tomcat and all the way back to the client. The client, whether it's a browser, mobile app, or third-party service, receives the response and processes it accordingly. And that's the complete request lifecycle when you hit a Spring Boot REST API endpoint. Let's review it all together. Step 1, the request is received by embedded Tomcat. Step 2, it's passed to the dispatcher servlet. Step 3, handler mapping locates the controller. Step 4, the controller logic is executed. Step 5, the HTTP message converter handles the return value. And step 6, the final response is sent back to the client. It all happens in milliseconds, but every step is essential for delivering a clean, RESTful response. That is what happens when you hit a Spring Boot REST API endpoint. Next, what is IOC, inversion of control, in Spring? Inversion of control is the fundamental principle of Spring. It means that instead of your code creating and managing objects manually, the Spring container creates, manages, and injects them for you. This removes tight coupling between classes and improves flexibility and testability. IOC allows you to focus on business logic while Spring handles object creation and lifecycle management. The container reads configuration metadata, identifies beans, and wires them together based on your definitions. IOC is especially useful in large applications where managing dependencies manually becomes complex. It also helps in unit testing because you can easily replace dependencies with mocks. In interviews, highlight that IOC is not just object creation but a design mindset where control is given to the framework instead of the developer. Next question: what is dependency injection in Spring? Dependency injection is the mechanism through which Spring implements IOC. Instead of a class creating its own dependencies, Spring injects them from the outside. This is usually done through constructor injection, setter injection, or field injection. DI reduces coupling, increases maintainability, and makes testing easier. When dependencies come from the container, you can swap implementations without modifying business logic. Spring recommends constructor injection because it ensures immutability and makes dependencies explicit. Setter injection is preferred for optional dependencies. Field injection is generally discouraged because it hides dependencies and makes testing harder. In interviews, emphasize that DI supports modular architecture, easier unit testing, and clean code. It is one of the core reasons Spring became so popular. Next, what is the Spring IOC container? The Spring IOC container is the heart of the framework. It is responsible for creating objects, configuring them, managing their lifecycle, and injecting dependencies. The two main container types are the BeanFactory and the ApplicationContext. BeanFactory is a basic container that provides lazy initialization and lightweight dependency injection. ApplicationContext is the advanced container that adds internationalization support, event handling, annotation scanning, and automatic bean post processors. Most modern Spring applications use ApplicationContext because it initializes beans eagerly, provides better integration with Spring modules, and supports annotation-based configuration. In interviews, explain that the container reads metadata from XML files, Java configuration classes, or annotations to assemble your entire application automatically. Next, what are Spring Beans? Spring Beans are objects created, configured, and managed by the Spring container. Each bean represents a component of your application, such as a service, repository, or controller. Spring decides how the bean should be instantiated, what dependencies it needs, and how long it should live. Beans can be configured using XML, Java configuration, or annotations like component, service, repository, and controller. A bean may have different scopes such as singleton, prototype, session, request, or application. The default scope is singleton, meaning Spring creates only one instance of the bean per container. In interviews, mention that Spring Beans help achieve loose coupling because developers do not manually manage object creation. Next question: what is bean scope in Spring? Bean scope defines the lifecycle and visibility of a Spring bean. The most commonly used scope is singleton, where only a single instance of the bean exists for the entire container. This is the default. Prototype scope creates a new bean instance every time it is requested. This is used when the object contains state that must not be shared. For web applications, additional scopes exist. Request scope creates a new bean per HTTP request. Session scope creates one bean per user session. Application scope creates one bean per web application. Understanding scopes is important because incorrect usage can lead to memory issues or unexpected shared state. Interviewers look for clarity on when and why different scopes are used. Next, what is autowiring in Spring? Autowiring is Spring's feature for automatically injecting dependencies without explicitly specifying them in configuration. It matches beans based on type, name, or constructor arguments. Spring supports several autowiring modes such as by type, by name, constructor, and annotation-based autowiring using autowired. Autowiring simplifies configuration but can cause issues when multiple beans of the same type exist. In such cases, qualifiers or primary annotations help resolve ambiguity. In interviews, mention that autowiring reduces boilerplate, keeps configuration clean, and integrates well with annotation-based development. Next, what is the difference between BeanFactory and ApplicationContext? BeanFactory is the basic Spring container. It provides simple dependency injection with lazy bean initialization. It loads beans only when they are requested. ApplicationContext is a more advanced and feature-rich container. It supports event publishing, internationalization, annotation scanning, and bean post processors. It loads all singleton beans during startup, which improves performance at runtime. Most modern applications favor ApplicationContext because it integrates better with Spring MVC, Spring Security, and Spring Boot. Interviewers often ask this question to check if the candidate understands Spring's internal architecture. Next, what is Spring? AOP. AOP stands for Aspect-Oriented Programming. It allows developers to separate cross-cutting concerns such as logging, security, transactions, metrics, and auditing. Instead of writing duplicate code across multiple classes, AOP lets you write one aspect that applies to many methods. This reduces clutter and keeps business logic clean. Spring AOP is proxy-based and works mainly with method-level cross-cutting functionality. Interviewers expect you to explain that AOP helps eliminate repetitive code and makes applications easier to maintain. Next, what is the role of @component, @service, @repository, and @controller? These annotations are Spring stereotypes that mark classes as components managed by the Spring container. Component is the most general stereotype used for any Spring managed class. Service represents service-level classes that contain business logic. Repository represents data access classes and adds exception translation for database operations. Controller represents web layer components in Spring MVC. Using these annotations helps Spring automatically detect and register beans through component scanning. They also make the application architecture cleaner by clearly defining the role of each layer. In interviews, emphasize that these annotations improve readability, structure, and maintainability,